Hello, everyone. Thank you for attending this webinar about business data analytics. My name is Khalid Santina. I work as a master trainer at Institute I4, which is an endorsed education provider, premier education provider of uh, business analysis courses and business data analytics and agile practices as well. We also provide uh, PMI courses such as the PMP, the Agile Certified Practitioners, and PMI PBA for business analysis. Today's webinar is about uh, introducing what is business data analytics. So we get to know what is that practice and what's the difference between BDA and BA and data analysis. Also, we will introduce a case study to show that when business analysis and data analytics join together, uh, we get great benefits from this merge. And then we will move into questions. So let's start with the introduction. Data analysis is defined as the process of inspecting, cleansing, transforming, and modeling data with the goal of discovering useful information, forming conclusions, and supporting decision making. So mainly data analysis is about treating uh, data to support business decision making. But we have seen um, uh, some gaps when data analysis is used alone without the proper support from business analysis. So the other practice is the business analysis, which is the practice of enabling change in an enterprise by defining needs and recommending solutions that deliver value to stakeholders. So business analysis mainly focus on enabling successful changes in enterprises. And for the last 20, 30 years, we have been experiencing high failure rate with change initiatives, and mainly there are many reasons for those failures, but one of the dominant reasons why change initiatives fail is the lack of proper business analysis. And that was one of the recent researches and studies that mentioned this was the PMI's research about project failures. They said that 40% of the projects that fail mainly is because of poor requirements management, and that means poor business analysis. Business analysis and data analytics are mainly two separate disciplines. As we saw from the definition, here the focus is on treating data to support decision making, and here enabling change to deliver value. But uh, when those two practices um, are used to manage data analytics initiatives, then better results always come into the scene. So as we see here, the focus of the data analysis is in a systematic process to observe, predict trends and patterns in data. So mainly the data analyst focuses on discovering whether there are patterns or trends in data, so that it makes those patterns and trends available for the business people and decision makers, just to know whether it means anything for their business. And this is where the business analyst role comes, to interpret those patterns and trends, try to know what is their meaning for the business, and also to set the right context for the data analytics initiatives, because without without business context for these initiatives, usually the data analytics initiatives would go into loops of discovering or collecting data, trying to treat those data, modeling them, presenting them, but without any uh, meaningful purpose for using those data. And this is why the business analysis should define the focus for the analytics problem and sets the scope, so that we know exactly what is the type of data we are looking for and what we are going to do with those data. And later in the data analytics initiatives, the business analysts will use the results of the data uh, to interpret their meaning. What do they mean to the business, and what is the best decisions that we can make uh, out of those uh, interpretations. And just a quick example to show you why the data without a good context is meaningless. Like if you look at this list of numbers here, what comes to your mind? What are those? Are those uh, like amounts of dollars of purchases? Or are those probably salaries of different people? Or are those installments for a big purchase? What are those? There are many ideas that can come up to our minds, but without any additional information support those data, we cannot get what are those. If I added, for example, another column, so here we have names of people, and when I associate these numbers to those people, probably I would start to limit the assumptions or the probabilities and try to say, oh, those probably are salaries of these people. But when I see repetition here, um, okay, maybe those are things that people are purchasing, the total purchases of those people for the last 3 or 6 months. And also we can go on with our assumptions. But when I give you more information about those numbers or data, now those makes more sense. It looks like these people are salespeople, and these probably are their sales achievements per country per quarter. Similarly, the business analysis, when when it's used um, in conjunction with the data analysis, it can give better context to the data analytics initiatives, so that uh, they so that we can use those data better to interpret their meaning and uh, enable the the business to make better decisions. Our case study today is about Uber. The problem that Uber was observing is that in one of the world cities was that customers were complaining about their trips to the airport being canceled by the drivers. So what was happening is that customers, they search for a ride, they want to go to the airport, they search for a ride, and then confirm their trip with a driver. But after the driver accepts the trip or the order, after a few minutes, in many times those drivers were just canceling their trips. And now the customer is in a situation that he wants to reschedule another trip sometimes Uber application, we're just helping those customers by finding automatically another driver. But that means more waiting time for those customers. And when you are going to the airport, that means you're trying to catch a flight. And for you, the time is very sensitive. So, and sometimes even those cancellations were being done more than one time with one customer. So uh, that makes it even more worse. So that customers are not sure whether they will be able to catch their flights or not. If I am confirming a trip and then my trip is being canceled and then I have now to catch another ride and this ride is being canceled and so on. So for 2 3 times, then I have to find another alternative. So this was the problem that the customer were complaining, and this complaint rate were increasing recently. So what happens, the business as usual, someone who's responsible probably for the customer service or managing Uber operation at that city thought that collecting some data and looking at those data would solve the problem. And this is why he called a data analyst. And the requests were as follows: bring me all the data of the canceled trips to the airports, but without specifying what is the objective of those data, what he's going to do with those data. There's no idea yet. Probably he wanted to watch for some patterns. So the data analyst just responded to the request. For him, the data is available there. So the data analyst extracted the data related to the cancer trips and then handed it over to the manager. The manager started looking at the data, trying to probably get some patterns or come up with some observations. He came to nothing yet. And he find it probably difficult that looking only at those data, he can't see any patterns, any trends. So he asked or requested the data analyst to look for the relationships between reviews and cancellations. And here he started to make assumptions as usual, trying to think about what factors could be related to those cancellations. Is it probably related to the customer reviews rate? And this is why the drivers, when they see the customer review is below average, they wanted to cancel the drive or the ride. Okay, then the data analyst brought those information about the customer review, and then the manager tried to analyze those data, but nothing serious was found. Then the manager asked the data analyst to arrange those data by customer zone, hoping to find probably relationships between the cancellations and probably where the customers are coming from probably specific zones in the city. But also this led to nothing. And more random requests or requests based on assumptions, but without deep thinking, uh, continued to follow. And the data analyst was responding every time, but nothing yet. And here, the management decided to engage a business analysis professional so that it helps in this problem. And this is what we were trying always to say, that when people start with data analysis without good understanding, without good foundation of what they are trying to achieve, without deep thinking with the problem or the need, they can go through the activities or the tasks of the data analysis. But usually this leads to little value because there is no uh, proper context or proper scope is defined for that initiative. But when data analysis initiatives start with business analysis, where the need is properly analyzed and the right questions are asked, then the result is usually different. Because even when we collect the data based on the business analysis, we can either have better insights and better interpretation of those data, always by associating and connecting the results of the data analysis to the main problem or the business need. And here we can get to great values if we pass through the process uh, that way, not that way. So now the business analysis professional is engaged and is trying to figure out what are the next steps for us to discover the problem, why the cancellations are happening. And then after some thinking, we came up with those questions. Is the cancellation rate at the airport is more than the city average? So with this question, we're trying to validate the problem. Is this a real problem, or probably the complaints of the customers are not uh, are probably meeting the average, but because of other reasons. Since when the problem is there? So we're trying to get history about the problem to see whether this is something that recently happening or is there since long time. Is there any trends or patterns for the occurrence of the problem? What happens after cancellation? So we want to know those drivers, what they are doing after cancellation. Is that they are engaged in other rides, or is that they are doing something else? So we have defined the questions that we want to answer. And based on that, we define the scope and the type of the data we need. And based on that, some structured and unstructured data has been collected and analyzed to answer those questions. So unstructured data could be something like the complaint tickets or information that we find in emails. Okay. Mostly they are not organized in a database, while structured information are things that can be found in the database of the systems. So definitely Uber, because they have systems connected to different databases, there are a lot of information that can be found there. Also, the type of information or data we want was the time lapse between cancellations and the next driver's trips, so that we know what is going on after cancellation. So those was some of the data types that we asked for. Now, to answer the first question, whether the cancellation rate at the airport was uh, similar to the average of the cancellation rates of the city, we decided, or the business analyst decided, to use the CBR ratio, okay, the completed by request ratio. And that is equivalent to the number of the completed requests divided by the total number of the total trip. requests. And that ratio gives an indication on how reliable is the market, the supply and the demand market. And it means that the higher this ratio is, the more reliable the market is, because we have the number of completed requests relatively high uh, compared to the total number of trip requests. So the higher the CBR ratio, the better was the market. And the business analyst requested that those CBRs to be grouped into the zones, the city zones. So we can even use a visual map like this to figure out what are the CBRs at different areas in the city. But also we can use something like the bar charts. And the results came as follows: that in all of these zones of the cities, the CBR ratio is close to 90%, close to 90%. And that is, and this is the average of the CBR, which is, which means that the CBR ratio, or the number of the completed requests, is really high compared to the total requests. And this is why the customer complaint at the other areas um, is not high. But why at the airport was 60%? That means many of the requests uh, end up incomplete when you compare it to the total trip requests. So for every 100 requests, there are 60 that that are completed. 60 requests are only completed out of 100. This is what it means, which means there are 40% of the requests being canceled. Now, to answer the other questions, the business analysts also depicted the figures uh, using different charts. So here, when we depict the data uh, uh, over a long period of time, since probably Uber services started in that city, we get that chart. So what we see here, what we observed here is that when Uber services started in that city, the CBR rate for the airport was really close to that for the city. But with time, it started to decline until it reached like 50% level after 6 months. Then, along with more time, it started to rise up a little bit slowly until it reached 60% recently. So there is a rising trend here, which means the CBR rate is getting better, which means there is less cancellation compared to the other historical period up to this point. And that is uh, really strange for for this CBR rate, because it started as normal, then it was declining. It means that something was happening here until this reached 50% level, and then it is improving but very slow. When we zoom in those data to look at the uh, last month data, we can notice here some patterns in the data. So for example, these are the days of the week, because the pattern here, as you see, is repeating on weekly basis, and we can see that the CBR is better than in at some days of the week, better than the other days. So we have 4 days where the CBR is better than the other 3 days of the week. But even the fluctuation in the CBR is around 20%. So still, that means that the cancellation rate is high uh, most of the time. So this data is just giving now some patterns. And we can, based on those patterns, we can make assumptions, right? Why this is happening, why this trend is there, why there is a pattern here, what is going on. Also, to answer the other question, what drivers were doing after cancellation, we were just looking at the data that tells us whether drivers were engaged in other rides after cancellation or not, or probably they are going home or out of the service. And the data shows that 97% of the drivers that canceled trips to the airport were engaged immediately after cancellation with other rides, with other customers. And those rides, when they are further analyzed, they were not related to the airport. So the drivers had a preference to cancel airport rides and take other type of rides, heading to destinations but not to the airport. And we have 3% of the drivers uh, just decided not to work at that day. So there are like 4 or 3 hours uh, after they have canceled the uh, the trips, uh, they went off the system for long period of times. So this is what the data says. Okay, there are a trend, there is a pattern. The drivers are engaged in other trips. Now, again, we can go and do many assumptions about those data. Why this is happening? Why the drivers are doing that? So instead of keep going into loops with data, what we need to do here is that the business analyst decided to go and interview the drivers, or probably running a questionnaire or survey with them. So some interviews have been arranged with number of drivers who have been canceling trips to the airports, asking mainly why the cancellation happened. And here the drivers expressed their or justified or explained their behavior by saying that airport rides are not really attractive for them. Why? Because first, the distance is long. And when they arrive there, they were hoping to get another customer, to pick customers from the airport, because they don't want to come back empty. Because if this scenario happened, they just consider the trip as uh, not worth it, because to travel for a long time empty, this is a high cost for the driver. So they hope that they get customers from the airport. But this is somehow difficult because what will driver do to it will wait for a new request for customer who wants to go from the airport to the city. but that wait time is usually long. May take like 1 or 2 hours for half an hour, 2 hours sometimes for the taxi driver or for the Uber driver to get a customer. At the time that this driver could have done many other trips if he kept inside the city. So this is mainly the reason why those airport drives are not attractive. Okay, now having this in mind, what will happen is that once a driver uh, um, accepts a request to go to the airport and probably move his car to the airport, directing to the airport, if another customer inside the city requested a drive and he was able to catch that call, the driver changed his mind. He no more wants to continue with the airport call. He wants to switch now to the other call inside the city because he knows that uh, the probability of waiting there at the airport uh, would be a high chance for a long time. So now we know the problem. By asking the right questions and uh, using the data wisely, now we were able to define what is the problem. And having defined the problem, now we want to start thinking about what possibly can solve this problem. How can, and here are two questions, two important questions that the business analyst uh, uh, were asking. How can we reduce the driver idle time waiting at the airport after dropping a customer? And mainly, if we understand why this idle time is there, uh, we can probably answer this question. And with further analysis, we've just discovered that the idle time is that there is no match between the supply and the demand. Like by the time the driver arrives at the airport, for him to find a customer from the airport, that means there should be enough number of customers at the airport. And that depends on what? On the arrival, on the arriving flights at that time. So if there is no enough flights arriving at that time, the waiting time would be longer. So in a way or another, the the waiting time of the driver depends on whether there is departing flights and arriving flights at the same time. But this match between the arrivals and departures is not under our control or the driver's control. So what will happen in this case? How we can optimize this? Is there a way we can optimize this? So what happens or what we can do is that we can figure out probably a way to forecast the time based on the departures and the arrivals. If we've got to get the data of the flights departing and arriving at a time in the airport, then probably we can come up with a time forecast of how long the driver is expected to wait at the airport. But also other factors comes into play here because also depending on the number of the drivers at the airport, because if there are many drivers at the airport, that means also the Uber driver will wait longer. So there is some factors that we need to consider to be able to come up with a time forecast and to help the drivers make decisions whether they want to go to the airport or not. The other factor is how can we motivate drivers to continue the airport ride request when the time is long? Because still, even with that forecast, even with that forecast mechanism, we still have times where drivers have to wait long time, right? So is there a way that we can motivate them? Yeah, by increasing probably the fees when they pick a customer from the city to the airport, the fees would be higher than usual. So now our solution is mainly evolving around those two ideas. If we can enhance or if we can come up with a with an accurate time forecast, then we can uh, improve the decision making for the driver whether to go or not. And still, if the time is still long, probably we can motivate the driver to uh, to go to the airport and still feeling that this trip is really worth it, even with the long time of waiting. And then here we switched again to the data analysis because the forecasting model that we come up with really depending on collecting data from different sources. One of the main sources that we want to collect data from in order to build this prediction model is the flights data. And that was really easy because the data, the flight data is available on the airport's website. So at any time, if we visited the airport website, we can find information about the data, about the flights departing and about the flights arriving. So by trying to figure out the density of the flights departing and those arriving, we can start building a forecast about the supply and the demand at the airport at that time. Of course, we need to know the exact time of the departure and the arrivals so that we can optimize this forecast. Also, we want to collect data, real-time data about the actual ride requests from the city to the airport. And not only to the airport, but also over all the city because now the customers, all the customers in the city are competing uh, over the drivers. So so we need to know what are the actual requests, how many requests are being processed at a time to the airport and from the airport as well, from inside the city as well, and also the data of available drivers, how many drivers available at this time. By combining those information, we can feed them to the artificial intelligence prediction system. But also this system is considering patterns from historical data about uh, those conditions. So whenever we have those parameters at certain levels, what are the patterns of the historical data shows about the waiting time at the airport? So these patterns are built by using the machine learning, and this is a complicated, could be a complicated system by itself, but then we feed those in data to the artificial intelligence prediction, and from those two sets of data, the AI would be able to come up with a waiting time forecasts and set the fair fee for the customer and the driver based on the waiting time forecast. So for example, if the waiting time is 15 minutes or 20 minutes or less, let's say, okay, so no need to set a higher fee. But if the waiting time is between 20 to 30 minutes, then probably would increase the fees by 20 or 30%. When the waiting time forecasts are more than 1 hour, probably we would set two times fees. Uh, so those data and decisions that the AI would come out with would be communicated to both the customers and the drivers so that they can make decisions whether they want uh, to catch or to accept requests of rides to the airport or not. And now uh, they have insight about how much time they are going to wait and how much fees they will be able to collect from this trip. And based on it, they will be able to make decision. So the solution were about predicting driver waiting time at the airport, setting the right fees based on the predictions, share the information with the customers and drivers, and also one thing we want to do is to limit the new ride requests to drivers who accepted airport rides so that we reduce the probability that the driver even change his mind after confirming a request. So that also was one of the recommendations that the solution of the solution. Now, what is the conclusion out of this case study? The things that we conclude here is that data analysis may be used to discover business problems. So we've seen here how we use the data in order to deepen our understanding of the business problem. But also, the data analysis can be used to solve the problem, but because our solutions can be also based on data analysis. Data analysis doesn't need always to be complicated. Data analysis not always means using artificial intelligence, doesn't mean always using big data technologies, doesn't mean always machine learning. It can be done at a simple level. We're using simple tools. Although if we want to work with data analysis uh, at an advanced level, of course, we want those tools. But this is not always the case. Data analysis doesn't need always to be that much complicated. But it's important that we are able to figure out the right questions. And I've seen cases in many times where people consider that data analysis is always dealing with databases, using programming languages, and advanced visualization tools. And that is not correct. It's not always the case. We can use data analysis at a simple level to help us make decisions in business. So for example, the data collection doesn't always need to be extracted from existing systems or databases. Okay. It can be collected using surveys and questionnaires. Uh, Data analysis could also be done by extracting data from unstructured information. And in many times, people just ask the wrong questions, and that lead to wrong decisions with data analysis, and that could possibly uh, drive people into going into the complication scenarios for data analysis at the time. If they ask the right questions, they can solve the problem using data analysis at a simple level. Also, data analytics efforts can be time wasting if not driven by business analysis. So when we ask the wrong questions, when we don't know how to use the data properly, what happens is that we always ask the data analysts to bring new data and probably to come up with new charts or figures. And then we discover that, oh, we are not able to do much with those data. So let's have those data in a different way, presented in different way, or probably add new set of data, right? And here it goes forth and back between the person who's trying to use the data and the data analyst. So this is why the business analysis skill and practice is so important to save time and to to set the right context and the right focus for the data analysis initiatives. At the end, I want to say that business analytics can be applied in at several areas in our business to serve different type of needs. Like we can use business analytics to figure out or understand who are our customers, to have deep insight about our customers. We can use analytics to improve and manage our reputation, our business reputation. We can use business analytics to improve operational efficiencies by discovering problems and sometimes helping in automating processes and procedures. Of course, financial management by having or measuring the financial performance of the organization using the data. We can judge whether the performance is accepted or not. Manage the waste, fraud, and abuse by trying to detect unusual behaviors. Also, in the proactive risk management, so that we can detect uh, signs of risky scenarios for our business. So we can use the business analytics or the business data analytics throughout different areas in our business. And finally, I would like to thank you so much for attending this webinar. I hope you enjoyed it. And if you need any services related to business analysis or business data analytics, you can contact me using the email or LinkedIn directly. Thank you so much. Goodbye.